how Hadoop works and what you can do with it and what big data is. I've done a lot of big data projects in Australia, in Canada, in the United States, and I'm also a learning tree instructor. Okay, so why big data? Firstly, we all know that governments and businesses are all gathering lots of data these days. Movies, images, transactions. But why? The answer is that data is incredibly valuable. Analysing old data lets us do things like detect fraud going years back. These days too, disk is cheap. We can afford to keep all that data. But there's a catch. All that data won't fit anymore on a single processor or a single disk. So we have to distribute it across thousands of nodes. But there's a good side to that. If it's distributed and we run in parallel, we can compute thousands of times faster and do things we couldn't possibly do before. And that's the trick behind Hadoop. Okay, how does Hadoop work? Suppose what I wanted to do was look for an image spread across many hundreds of files. So first off, Hadoop has to know where that data is. It goes and queries something called a name node to find out all the places where the data file is located. Once it's figured that out, it sends your job out to each one of those nodes. Each one of those processors independently reads its input file. Each one of them looks for the image and writes the results out to a local output file. That's all done in parallel. When they all report finished, you're done. Okay, we've seen one simple example of what you might want to do with Hadoop, image recognition. But there's a lot more to it than that. For example, I can do statistical data analysis. I might want to calculate means, averages, correlations, all sorts of other data. For example, I might want to look at unemployment versus population versus income versus states. If I have all the data in Hadoop, I can do that. I can also do machine learning and all sorts of other analysis. Once you've got the data in Hadoop, there's almost no limit to what you can do. Okay, we've seen that in Hadoop, data is always distributed, both the input and the output. There's more to it than that. The data is also replicated. Copies are kept of all the data blocks so that if one node falls over, it doesn't affect the result. That's how we get reliability. But sometimes we need to communicate between nodes. It's not enough that everybody processes their local data alone. An example is counting or sorting. In that case, communication is required. And the Hadoop trick for that is called MapReduce. Let's look at an example of how MapReduce works. What we're going to do is take a little application called CountDates that counts the number of times a date occurred spread across many different files. The first phase is called the map phase. Each processor that has an input file reads the input file in, counts the number of times those dates occurred, and then writes it as a set of key value pairs. After that's done, we have what's called the shuffle phase. Hadoop automatically sends all of the 2000 data to one processor, the 2001 data to another processor, the 2002 data to another processor. After that shuffle phase is complete, we can do what's called a reduce. In the reduce phase, all of the 2000 data is summed up and written to the output file. When everybody is complete with their summations, they report done, and the job is done. Okay, we've seen a couple of great examples of how Hadoop works. The next question is, how does Hadoop compare to conventional relational databases? Because they've dominated the market for years. We've seen one big difference, which is that in Hadoop, data is distributed across many nodes, and the processing of that data is distributed. By contrast, in a conventional relational database, conceptually all the data sits on one server in one database. But there are more differences than that. The biggest difference is that in Hadoop, data is write once, read many. In other words, once you've written data, you're not allowed to modify it. You can delete it, but you can't modify it. By contrast, in relational databases, data can be written many times, like the balance of your account. But in archival data, which Hadoop is optimized for, once you've written the data, you don't want to modify it. If it's archival data about telephone calls or transactions, you don't want to change it once you've written it. There's another difference too. In relational databases, we always use SQL. By contrast, Hadoop doesn't support SQL at all. It supports lightweight versions of SQL, called NoSql, but not conventional SQL. Also, Hadoop is not just a single product or platform. It's a very rich ecosystem of tools and technologies and platforms, almost all of which are open source and all work together. So what's in the Hadoop ecosystem? At the lowest level, Hadoop just runs on commodity hardware and software. You don't need to buy any special hardware. It runs on many operating systems. On top of that is the Hadoop layer, which is MapReduce and the Hadoop distributed file system. On top of that is a set of tools and utilities, such as Hadoop, which is statistical data processing using the R programming language. There is a machine learning tool. There are also tools for doing NoSQL, like Hive and Pig. And the neat thing about those tools is they support semi-structured or unstructured data. You don't have to have your data stored in a conventional schema. Instead, you can read the data and figure out the schema as you go along. Finally, we have tools for getting data into and out of the Hadoop file system like Sqoop. That ecosystem is constantly evolving. So for example, there's now a new tool for managing the pig tool called Lipstick on a Pig. And there are many more, and that environment keeps being added to all the time. So now we've seen how Hadoop works and what it can do. I'm sure you've got more questions than that, such as, how do I install Hadoop and on what platforms? The differences between different Hadoop versions, or how to do extract, transform, and load in Hadoop.